Hello guys, how are you doing? I hope you are doing well. I hope this video will be clear and it will be enough for this method. Uh, in the beginning, this is a problem of a test exam 2. So we wrote the system equation as it a x equal y, and the first step to do is putting the arrangement of every row, or the numbering of every row. So this is the first row, this is the second row, this is the third row, this is the fourth row, and while we are doing any movement, this arrangement has to be moved also. So the first step is choosing the maximum magnitude value in this column, which is 4, and then we rearrange this, we interchange this row by this row. That's what we have done here in the first step. Why we are doing this rearrangement and we are moving it while we are working? Because this will give us the P at the end. P, the permutation matrix, which is P2, P1, whatever, but now we will have it directly after we finish solving this problem. So now we want to reach to LR decomposition. We want to arrive to L, lower triangular matrix, and which is here, and upper triangular matrix, which is here. But let's say that this lower triangular matrix will be with diagonal 1. So sorry for coming here and coming back, but what can we say now? That after this step we want to make all elements under the diagonal 0. So we do that in every column, and then we record this step and we will see how to record it. So now we want to make this element 0 and this element 0 and this element 0. So what we do, we multiply the first row by -1/4, and then we add it here, -1/4, and then we add it here, -1/2, and then we add it here, and we don't forget to make all the process for the whole row. So what after doing that will be the result. We can say about this matrix is L1A, whatever, it doesn't matter. We don't need that step, but we need only to do this submissions on this row. So 1, -4, 0, -1, negative row multiplied by 0 is -1, 1, -4 multiplied by 1 is 1 -0.25, which is 3/4, and then we continue. So now here is the first thing to concentrate on. It's the lower triangular matrix. So first we will construct it as a lower matrix with diagonal 1. So now we have here constant ones, and we have here zeros, and we will not change these zeros. And what did we do to make this element 0? We multiplied this row by -1/4. So we put here the inverse of -1/4, which is 1/4. Now we are making two steps in one step. We don't need to get L, and the end we get L inverse by the calculator or whatever. No, we will get L inverse and L in the same step. So here we multiplied by -1/4, so we write here 1/4. We multiplied here to make this element 0, we multiplied 4 by -1/4, so we write here 1/4, and here we multiplied by -1/2, so we write here 0.5, which is 1/2. Then the next step is looking at the second the second column. We want the maximum element here to be the diagonal. The diagonal here is A22, so we want A22 to be the maximum. So we take the magnitude of all of these three elements, and the maximum of them is 1. They are the same. So in this step we will not do any rearrangement. We will not change here the order. Everything will stay the same. Then what do we need to do? We want to make this 0 and this 0 the elements under the diagonal. So we add this element to this element, we multiply here by 1 and add it to this, we multiply here by 1 and add it to this, and taking the inverse, which means the inverse of 1, because I multiplied here by 1, so the inverse of 1 is -1. So here in the lower triangular matrix I will write -1. And also for this element, what did I do? I multiplied this row by 1 and I added it to this element. So I multiplied by 1 and the inverse of 1 is -1. Actually the inverse of -1/4 is 4, but here we can only say about the inverse is taking the negative value. So now we have L. Here these two zeros become -1 and -1. Here this 0 stays the same because we didn't do anything right now for this element. And then we deduct our matrix. Now we add this row to this row and put it here as this, and then we add this row to this row and put it here as this. Now we are converting to the third column. We want to make the diagonal here the maximum, the element of the diagonal, which is A33. We want it to be the maximum of these two elements. So we take the magnitude and then we will find that 0.75 is bigger than half, so we will rearrange those two rows. And now we have to take care. We made this rearrangement, so this 3 becomes the last and this one become here, and this rearrangement will reflect also on L. So the elements we have here, we changed 1 3 1 3 1, so we have to rearrange both rows, but only the elements we have worked on. So we will here we will interchange this row by this row as we did here. 3 1 become 1 3, so 0.25 and 0.5 we will rearrange them, but we will rearrange only the part under the diagonal that we have worked on. We will not move the whole row. We will not interchange both rows. Only this row under the diagonal and only this row. Here we didn't make anything right now in this element. In this matrix, we didn't do anything in this element. So this element here stays 0 in L matrix. Now we want this element to be 0, so we will multiply here by half. We will multiply by half over 3 over 4. So I don't know which is the accurate thing to write, but we will calculate this row again. This row will stay the same and the element under the diagonal will be 0, so we will multiply here as we have said by half over 0.75, and then we add it here, and then we will make the whole change to the whole row. And to make this element 0, we multiplied this element by half over 3 over 4 as we said. So it will be 2 over 3, and this value, when we multiplied by it here, it was positive, so we will write it here the inverse of it, so it will be written as a negative value. So this is L, lower triangular matrix, and this is R, as we have said. And here now we have the system of the Gauss elimination as on this form: Rx equal y, but it's not y, it's y multiplied by p multiplied by L inverse. And here the results, I mean this y. This is the original y, but it has the rearrangements and everything, and it has multiplied by L, and it has continued with our process. So this is here is L inverse py. This column, we can say about it, it's L inverse py. Whatever we can say about it, we can say that we have upper triangular matrix, and we will use the backward substitution. 1 over 3 multiplied by x4 equal 1 over 3. Negative 3 over 4 multiplied by x3 plus half x4 equal negative 4, and then we can continue. So I hope this was interesting, and you could get the L matrix, how did we get it, the R matrix, how did we get it. And see you later guys, and good luck with the exam.